going to learn two new formulas: surface area and volume of a sphere. So you've got a sphere that's like a ball, circular in shape, three-dimensional. And a sphere, just like a circle, has a radius. But in 3 dimensions, all the points on the outside of your sphere are the same distance from the center. Now, for the surface area of a sphere, the formula is 4 pi r squared. And one way that I sort of remember how to find the surface area of a sphere, so I imagine, like I have this golf ball here, if I look at it from my direction, and I think in 2 dimensions, it looks like a circle. If you look at it from your direction, it looks like a circle. So if we were trying to splatter this with paint, we've got one direction getting this side, one direction getting this side. But that would be the same as just a disc with no thickness. If we also looked from the top, we'd see another circle, and from the bottom, we'd see another circle. And so if, in theory, we'd spray paint from one side, another side, from the top and from the bottom, we would cover the whole thing. And so the surface area for a sphere is just 4 circles, 4 pi r squared. And the volume of a sphere has a fraction in it, 4/3 pi r cubed. Well, I can give you a calculus one, but you're not ready for that yet. Later. So we've got 2 new formulas, and again, what we're going to be doing is solving questions using these formulas. To start off with, here we've got volume and surface area of a sphere. So to draw a sphere, draw a circle from the center, label the radius, and so far, can you say that that picture does not look like a sphere, it looks like a circle? So how can we make it look like a sphere? Well, you can add an oval here if you like. That might give it some sort of depth when you're drawing a picture. Or maybe you like to shade things. Maybe the shading helps make it look more sphere-like, I'm not sure. So if we want to find the volume, our formula is 4/3 pi r cubed. We plug in everything that we know. We know the radius. And with our calculator, we can type this all in at once. So I go 4 divided by 3 pi. My radius is 12 cubed. So to do cubed, above your divide sign is a little hat button, which allows you to write an exponent. Push enter. 7,238. Since we're dealing with a volume here, it will be centimeters cubed. The units are very important. Our surface area formula is 4 pi r squared. Again, we can put our radius in there, go to our calculator, type this in all at once. 4 pi, radius is 12, squared. Now, right now, I'm typing things all the way through exactly as they are. If you don't like the brackets, does this make sense that if I use the times sign, that means the same thing? And we get the same answer. If I round that one to the nearest centimeter squared, it would be 1,810 centimeters squared. So this would be the most basic kind of question. You've got all the information you plug in volume, you plug in surface area, type it into your calculator, boom, you get the answer right away. More complicated questions look something like this. Find the volume of a volleyball if its circumference is 26 inches. So I want to find volume, so it might be that the first thing you do is write out your volume formula. 4/3 pi r cubed. And to find the volume, the only thing I need is a radius. But that's where this question's a little bit more complicated, because did the question tell us the radius? No. So knowing that, this tells me we need to find the radius. If I want to figure out the volume, I need to find the radius. What else did they give me? They gave me the circumference is 26 inches. So go to our formula sheet, look up our circumference formula, or maybe you have it memorized. Circumference is 2 pi r. We know our circumference is 26. And this is enough information to solve for a radius. And now we're going to get into calculator issues. Does it make sense that if I want to get the r by itself, I need to divide by 2 and divide by pi? That would, if I do that on both sides, the 2's will cancel, the pi's will cancel, and I'll get the radius by itself. And now I'm going to show you the most common calculator mistake, one of the most common calculator mistakes that grade 10s do. They go like this. And I need you to tell me why this is bad. It's 26 divided by 2 pi, right? 26 divided by 2 pi. Does that look good? That answer's wrong. What?
Is it because 2 and pi times themselves?
They do. 2 and pi times themselves.
Oh, yeah, that makes no sense.
Okay. Does that not look like it should be right? Yeah? What the calculator is doing here is it does order of operations, and it goes from left to right. So it does 26, it divides by 2, gets 13, and then multiplies by pi. So what we actually typed in here, what I actually typed in when I write this on my calculator is 26 divided by 2 multiplied by pi. The problem with that multiplied by pi is that has it on the top, not on the bottom. So how do we make sure we avoid this? Because it is really, when we look at our calculator, it looks like we just type in the right thing. Two ways that you could avoid this. One, you can use the fraction button. So if you go alpha, y equals, this menu comes up, push enter on the first one, and if you use the fraction button, it forces that pi to stay on the bottom, and we get the right answer, which is 4.14. The other thing we can do is if you don't have the fraction button on your calculator, you have to add extra brackets on the bottom so that that keeps the pi on the bottom with the 2. And if you did that, we get the right answer as well. So calculators are smart, but only as smart as the person using them, right? If you want to type in the wrong things, you can get the wrong answer. So we have to learn how do we get the calculator to do what we want it to. So now we have our radius, 4.138. And I'm going to show you a second common mistake. Okay? A second common mistake that a student will do in a question like this is they'll maybe, to really make the mistake obvious, I'm only going to write 4.1. Okay? I just rounded it to 1 decimal place instead of 3 decimal places. Common mistake is then a student will go to this put in 4.1 and cube it, go to their calculator and put in 4 divided by 3 pi bracket 4.1 bracket cubed. So I've typed in everything right, and I get my answer to be 288.7. Now I want to show you why this isn't quite right. Because I rounded early with the 4.1, that creates some errors with my final answer. If I didn't round early, 4 divided by 3 pi, and instead of going 4.1, I'm going to go up here and select all of those decimal places, bracket, cubed. How much does that change my answer? It's off by 8. Quite a bit. So in this example, if you wrote your final answer as 289, because you rounded early, your final answer would be off by 8 because the actual answer is 296.8. And only when you get to your final answer do you round it. So sometimes what I like to do in my work is, for my radius here, instead of writing 4.1, I might write 4.138 ... And that helps me remember that I'm not going to round that answer until my final answer. Is it wrong if you write 4.1 in here, but have a final answer that shows that you didn't round? No. So you can round in your work because no one's going to ask you to write all thousands and thousands of decimal places. That would be insane. But it's important that in our calculations, we don't round until the end, because that keeps our final answer as accurate as possible. What's a hemisphere?
Half of a sphere.
Half of a sphere. How would you draw a hemisphere? Half a circle. So I'll start with half a circle. And then, if you draw that oval idea on there, can you see a hemisphere now? You can add the fancy shading if you want to. I don't know. I don't know if the shading works on that one.
Use the crayon.
Use the crayon to shade it. So we have a hemisphere with a radius of 5. We want to find the volume, but we don't have a volume formula for a hemisphere. What are we going to do?
Just divide. You find the full volume and then divide by 2.
If we find the whole thing and cut it in half? Okay, so for a volume, we find the whole thing, 4/3 pi r cubed, and then take whatever answer we get and divide by 2. Do you like the divide by 2 that way, or would you like a divide by 2 after with do you like that better?
First way.
Do you like the first way?
Yeah.
Okay, the whole thing, I like this. The whole thing gets divided by 2. You can type this whole thing into your calculator all like that, all at once. So, I'll show you that. 4 divided by 3, pi, the radius is 5, cubed, divided by 2. If you want to on your calculator using the fraction button, you can do alpha y equals fraction button. 4 divided by 3 pi pi, the radius is 5, cubed, all divided by 2. You can do that all at once if you'd like, which is really nice. You could also figure out the full volume first, get your answer, and cut it in half at the end. 261.8. It doesn't tell us what we need to round to. If it doesn't tell you what you need to round to, you get to choose. 261.8. Our units are centimeters. Volume would be centimeters cubed. So my question is, if a hemisphere is half a sphere, and the volume of a hemisphere is half the volume of a sphere, why is it that the surface area of a hemisphere isn't half the surface area of a sphere? Let's wait. Why, when I calculate the surface area of this, is it not just going to be the surface area cut in half? There's a bottom that gets added, right? If I just do half the surface area of a sphere, I don't count the circle on the bottom. So to figure out the surface area of this sphere, the surface area of the whole thing is 4 pi r squared, and we need to cut that in half. That will give us the outside. But we also need to, okay, you convinced me, add the base. What shape is the base? It's another circle. What is 4 pi r squared divided by 2? 2 pi r squared. And 2 pi r squared and pi r squared are like terms. If you have 2 circles and you add another circle, you have 3 circles. So this formula simplifies to 3 circles, or 3 pi r squared. Plugging in our radius of 5, we get 3 pi times 5 squared. Now, leading you up to higher level math when you do math in grade 11 and grade 12. In this question, you can do 5 squared, right? 25. You can do 3 times 25, 75. So would you agree that this is the same as 75 times pi? The last thing I haven't multiplied is multiplying by pi. Okay? In higher level mathematics, they would get you to leave your answer like this. 75 pi centimeters squared. Because this answer is exact. There's no rounding that's taken place yet. As soon as I go to my calculator and say 75 times pi is equal to 235.6, now I've had to round. And so sometimes questions will say, leave your answer as an exact answer. This answer, 75 pi, in math words we say is an exact answer in terms of pi. So we left pi in the answer. And this answer is accurate, but it is approximation because we had to round. So the 75 pi later on in mathematics is seen as a better answer, but the problem with an exact answer is it's sometimes hard to visualize. Whereas this 235 centimeters squared, I can imagine 235 of those little squares covering the whole thing.